This video will show you an idealized view of the steps required to create a fertilizer prescription map or a seeding map for a farm field. It starts with GPS-equipped farm machines. GPS is the key to precision agriculture because it enables the mapping of variables like elevation and yield from the farm field. Yield and elevation are the two key variables that will be used to develop a prescription map. To compare yield or other variables from year to year, we create a grid of cells over the field to simplify calculations and comparisons. The cell resolution chosen for our work is 6 meters or 20 square feet. The farm equipment also provides an estimate of the land's height, which is mapped to produce a digital elevation model to be used for hydrology and the creation of a yield map. Here you can see the combine harvesting corn. Yield meters installed on the harvester are essential to precision agriculture, and in conjunction with GPS data are used to create yield maps for the farm fields. One of the first things they reveal is the high variability of the yield in farm fields. The forks at the front of the harvester neatly cut the corn stalks, remove the cobs, and then feed the cobs into the turbine in the center of the harvester. The turbine produces a stream of corn kernels that are fed up to the grain hopper on the top of the combine. As the grain is fed into the hopper, it is measured for weight. The weight and the GPS coordinates are recorded together. This allows us to create a map of the yield across the field. High yields are the blue areas, while the red areas indicate poor yields. Processing of the yield data into the map grid allows us to then compare the yield map with the elevation map. At this point, the data typically indicates that the knolls correspond to the lowest yields. We focus on a section of the field to see how the local field hydrology works. Every farm field has knolls and low areas known as pits or depressions where water collects. The natural movement of the fertilizers and other organic material in the farm field is from high points to the low. This sequence shows the filling, overflow, and continuous movement of water. It highlights the potential for nutrients to be transported in this flow. Field hydrology can be very complex, with streams often running in directions that seem counterintuitive. The overall effect is fertilizers being removed from higher areas while increasing concentration in lower areas. The creation of a prescription map involves yield maps, elevation maps, and a host of other variables not shown in this video. The calculations are complex and can take several hours, but the result is a simple map that matches the seed and fertilizer to the hydrology and pattern of high and low yields. In this video, the prescription map is shown as having 3 levels of seed or fertilizer. Although many more levels are possible, most farmers can make great economic use of just the low, medium, and high rates. New variable rate seeders and spreaders will use the map to deposit exact amounts of seed and fertilizer into each cell. The incredible flexibility of these new machines means that we will soon be able to address more than 3 levels to apply a prescription map onto a field. For additional information on the potential of precision agriculture and prescription maps, please contact us today.